All right, geometry, let's get started. We've got this next section here. It's about prisms and cylinders. So we're talking a lot about three-dimensional objects. I'm not sure exactly where we left off on that, but I'll talk more about that in a minute. What it is I need you to know by the end of the chapter, chapter 9. We're only covering 913, 914, and 915. The rest of chapter 9 we're not going to do. So we're going to do a lot of learning in a compact space. That was the plan before this virus thing anyway. But what I want to do is I want to do 3 or 4 of the problems out of the book to give you a sense of formulas and such. And then I will share with you a video on all the formulas for all the figures. But this introductory video of this stuff is a nice kind of first step to get a sense of how this works, okay? So our first question is about this box. And if I have a box like that, what would it take to paint it? What would it take, like, if I unfolded the box? Like if I got this box from Amazon or something. How much cardboard would that be? Now this matters to those folks who make boxes and work on shipping. There are people who get paid a lot of money to figure out how to do shipping for less money. So it's worth it to know how to do this. So this is that same figure, and what they did is they just used blocks. Like these are a bunch of little blocks all stacked together to show you a thing that ends up looking like the shape of a box. It has a width of 3 units, a length of 4, and a height of 2. This, right here, this thing, is what's called a net. In other words, if I took a razor blade and I cut this box here and so forth, and I laid it out like you got a box from Amazon, and you laid it out flat on the floor, it could look like this. Notice I said it could look like this. I could draw this net for this box in a number of ways. This one, to me, just kind of made the most sense. And if you think about it, it works. If I fold along these dark lines, right here, and I bring this side, actually I could bring it up, and I can bring these two sides up. I could bring this up, and then this piece would flop on over, and you would end up with this shape. What's also interesting is if you look, like I have a 3x2, this front face is a 3x2. Well, I decided to put that here, 3x2. And here's the other one, because if there's one in the front, there must be one in the back, so there's another 3x2. On the right-hand side, I've got a 4x2, and sure enough, here's a 4x2. And you can see that if this folds up, it'll have a height of 2. If this folds up, it'll have a height of 2, and this edge and that edge could be taped together. And if there's a right-hand side, there must be a left-hand side tucked behind here. So if this is the right, and then this must be the left. This is 2x4. And then finally, you have the top, 3 units by 4 units, and then you've got the bottom. I'm going to go ahead and call this the bottom, and this the top. I'm going to call this piece right here the front, and this is the back. We'll say that B is for bottom, not bikini bottom, whole different thing. Again, the top is 3x4, so check it out, 3x4, and same for the bottom, 3x4 for top, 3x4 for bottom. Now I'm putting all those in there for a reason, and you're probably like, yeah, I can see it, I can count blocks, and that's okay, but in a minute I'm going to kind of focus on each of those pieces. So that's the idea behind a net. You're just imagining you're taking this 3-dimensional object, breaking it open and laying it flat, just on the sides. By the way, talk a little vocabulary here. where you've got, you know, these 3 points coming together, that's called a vertex. This is called a face. This particular one is the front face, right face, top face, even the bottom face. Right here, this is called an edge. And yeah, that's about as much vocabulary as you need. So when you hear me use these terms, you'll know what I'm talking about. You could see like this two and that two would come together, that would create an edge, and in fact it would be this edge right here. All right, now I do understand that for some students, drawing three-dimensional stuff, or even seeing in 3 dimensions, when I got something on a 2-dimensional board and I'm trying to represent a 3-dimensional figure, I know that for some of you that's not easy, but I promise you I'm not going to make you draw this. I'll always provide images of the objects we're talking about, and you just need to pick out of the images what you need for the formulas for, say, surface area and volume. Okay, I'm not going to make you draw it, but I'll give you some hints on how to draw them if you want to. Okay, next thing I want to talk about is how to find surface area and volume, and I'm going to start with surface area, and I'm going to talk about that, getting that in 2 different ways. One way is to just go through the figure and find all the areas of each of these sides. That's one way to get it done. So, like for example, I've got a 2x3. The area of this rectangle, because it's 2 units by 3 units, is 2 times 3. But that's not the only one I have. I've got another one that has the same dimensions, 2 by 3. So I have 2 of those. You're going to see that pattern play out again and again. I have 2 by 4, so I need to have a rectangle that is 2 by 4. I got to account for that area, but I also have to account for this area, 2 by 4. So there's 2 of those. And last but not least, I have a 3 by 4. Now, what's nice about this is that I can cross this stuff out as I go, and then I know what's left. And oh yeah, check it, there's another 3 by 4. And now I've got every kind of shape accounted for. This is the surface area. In other words, this is how much cardboard you need. I don't know if this is in inches or feet or whatever. I'm assuming it's inches. It's a small box, but at the same time, this will tell you how much cardboard you need. Now you're probably sitting there going, well, what about the little tabs and the extra in the... I don't want to go there right now. That's extra. That's later. Later! So, for right now, what I want to do is just talk about if I just had the bare minimum cardboard and I could just tape the edges. Or put it another way, how much paint would it take? How much square units of paint would it take to coat this box? And notice I said square units. Area is always in square units. So if I'm talking surface area, it's still area. It's going to have square units. So I've got 6 times 2, I've got 12. 8 times 2, 16. And then I've got 12 times 2, I've got 24. That's 36, 42, 52. I hope I added this right. I'm exceptionally tired. 36, 42, 52. Square units. Okay? Now, I want to tell you that this thing is called a rectangular prism. And in a little bit, I'll show you or another video, I should say. I want to show you my formula in my gold sheet of that I like to use to get surface area and volume for prisms. So the surface area formula for prisms is 2 times capital B plus PH. Let me talk about what all those letters stand for. Notice that's a capital B. This is the area of the base. So now in this box, you're going to have to decide what represents the base. I'm going to consider the thing we can't see, the bottom of this, because a lot of students like to think bottom, base means the same thing. Doesn't have to, but I'm gonna say that the base, and for this box, is this 3 by 4, that's 12. But capital B means area of the base, capital B. P means perimeter of the base. And H is equal to the height of the prism. Height of the prism. It is not the height, like in a little while you're gonna see a triangular base prism. Triangles have base and height. So is it the height of the triangle or the height of the prism, right? So I'm trying to be super clear. This formula is for the entire prism. So the height of this prism is 2. The perimeter of the base is 3 plus 4. Oh, there's another 3 in the back, another 3 in the back, and another 4 on the left. 3 plus 4 is 7. Then I got another 3 and 4. That's another 7. That's 14. And then the height of this bad boy is 2. So I've got 24 plus 28, and that is 52. Now going forward, I'm going to use this formula because it's a really nice general formula for any prism. Real quick, before I go to volume, I want to tell you that with a box, it's kind of easy. This stuff is kind of easy. In a minute, we're going to talk about a triangular base prism. We're going to talk about a hexagon base prism, and we're also going to talk about a cylinder, and the base of that is a circle. And so we have to be careful with all of this. What is the base? In a prism, there's always a pair of figures. In this case, it's a rectangle, a 3 by 4 rectangle. And it's a pair of them that are parallel. The bases are always parallel. Okay, so that's a nice introduction of, well, what makes a prism? What's the vocabulary of a prism? Let's talk about volume. This, I'm going to do volume 2 ways as well. You know, volume for a box is just length times width times height. No big whoop. So I'm just going to go 3 times 4 times 2, 12 times 2. It's 24. It's volume. So the area has square units. Volume has cubic units. UN units. The general formula is going to be area of the base times the height. In general, when you get a prism, the first thing you're going to have to do to get its volume is to find the area of the base. Now, what they like to do, they being the people who come up with these questions, is let's say you're given this figure, they'll just like turn it like this, or like this, or whatever. And you'll have to discern what's the base. And you'll have to be careful. So the fact of the matter is that once you've figured out what the base is, remember it's always the same figure, and if you look, there's another one parallel to that figure that is sitting opposite it. Area of that base times the height. So my base is 3 times 4. That's the area of my base, length times width, and then my height is 2. Now with this box, it's pretty much the same set of numbers. In fact, it's the exact same in the exact same order. 24 units cubed. I'm going to stop this video for right now, but this is a nice introduction to what prisms are and so forth. I hope you took good notes. If not, rewind. If there's something in here that you don't understand, rewind. But the next thing I'm going to show you is a couple more problems that use these formulas.